Today's section 2.6, the graph of y equals k over x and y equals k over x squared. You'll probably notice that the last two previous sections, they only took one equation at a time. Now in this section, they are giving you both types of inverse variation graphs that we're going to study in this section. So it'll be a little more complicated because you're trying to keep two sets of equations separate in your mind. Now, to start with, you can see our goals. We want to be able to find those rates of change because we already said lines are really the only thing we can call the k-value slopes on. Parabolas did not have slope. They had a rate of change. We want to identify the properties of the different variation functions we're going to study, which we've been doing. So we will have even more lists of characteristics than the previous two sections. We want to graph the inverse variation and inverse square variation equations and start comparing them and identify different pieces and different parts. Okay, so let's look at what we've done already. We've had now, if we say total, if we add today's to it, 4 equations that we should be able to graph depending upon what k is. So when we say y equals kx, and we'll assume right now the k values are positive, we should know we would have a line that runs through the origin. Whoa, my lines aren't very good here. Runs through the origin, goes through the first and third quadrants. We know for y equals kx squared, it is a parabola that goes in the first and second quadrants. Again, goes through 0, 0. Is symmetrical. So you start thinking about all those characteristics that we can talk about. Now, the two new ones, y equals k divided by x. So it's an inverse linear situation, and it's an inverse as a square situation. Y equals k over x. Now, the graphs of both of these are slightly different. So I'm going to go right to our graphing calculator and see what happens with a couple equations of this style. Started out with the linear one, and again you can see y equals 2 over x is my red graph. Y equals 10 over x is my black or dark gray graph. I want you to look again at those two. Here we know we have a k value of 2, so k is positive, and in the second one we know we have a k value of 10. A couple things jump out right away. Definitely not lines, definitely not parabolas. So what do we call these? And actually I need to tell you that both red portions of this graph, both the one down below on the left in the third quadrant and the one up top in the first quadrant, are from the same equation. So if you think about it, start looking. When x was 1 in our first equation, if x was 1, y was 2, and we got that point. If x was 4 in that first equation, then we got an answer of 1/2. So you can see what's happening. As the smaller our x's were, closer to 0, we got points that were very small. So for example, if we put 1/2 in, an x value of 1/2, that would be the number 2 divided by 1/2. Well, 2 divided by a fraction, you never do that. 2 times the reciprocal, that's a 4. So when we have an x value of 1/2, we have a value of 4. So you can see what's happening. If we continue to do this for all numbers, we are getting that red curve. But if we turn around and put some negative x values in, if we do the same similar choices, if we said 2 divided by -1, put an x value of -1 in. So we're right here at -1. 2 divided by -1 is a -2. We would now be graphing that point there. If we put a 4 in, 2 divided by a -4, and that would give us a -1/2. So out here, when we're at -4, we get a -1/2. Put that 1/2 in. You're still going to get the same look. Make it negative. 2 divided by a negative 1/2. Well, that's going to put us down here at 2, negative 4. So when we put in negative numbers, we were getting all types of points on this curve. And if we did every single one possible, we would get this branch. And if we did all the positive x values we possibly could, fractions, decimals, everything, we would get this smooth curve. We don't have a name that would probably be common, like lines and parabolas to you, but you should know that this graph is called a hyperbola. It consists of two branches in opposite quadrants. Okay, so hyperbola. A hyperbola is the form of y equals k divided by x. And notice now, when we say start looking at the different k values, what happened to your hyperbola when we graphed the second form, which was very similar. The only difference was the k value was quite a bit larger. When k was 2, we had the pink or red branches, and now when k is 10, we have the dark gray. It's moving, as we say, away from the origin. Now, speaking of the origin, look real carefully. These branches never touch, never stop going. They're going closer and closer and closer, and you can get your own graphing calculator and find that out, but they never touch the x-axis. They never become 0. And if we would put a 0 in for x, think about it, we would have y equals 2 divided by 0, and we know that's undefined. And if it's undefined, that means we can't have anything graphed on our y-axis. So if nothing can land on the x-axis and nothing can land on the y-axis, these two branches look like they're independent, but they truly do come from one equation. So it takes care of the x values for that equation, and it takes care of the negative x values for that equation. So list characteristics, yeah, that would be another good thing to do. List the characteristics that go with your new equation, y equals k over x, and see what happens with your list, comparing it to your other two that you've already made in your other sections. Some of the characteristics, again, may be the same, and some of them may be different. All right, let's clean things up here a little, and let's see if we can edit our equations. I want to change this now to x to the power of 2. And down here, I want to change it to x to the power of 2 as well. And we now have a totally different graph. This is our second equation that we will be looking at, and it starts y equals k all divided by x squared. It's called an inverse square equation, so we call that an inverse squared graph. Now notice again, we have that same situation where if we tried to put in a 0 for x, we'd be looking at 0 squared, which we know is 0, and anything divided by 0 is undefined. So we have that situation where you're not going to see anything graphed along the y-axis. These branches are getting closer and closer and closer to 0, but never touching, never crossing. Now again, think of your equations that you have. We're getting points, just pick an x value of 1 in that top equation. When x is 1, 2 divided by 1 squared would give me a 2. When x was 2, 2 divided by 2 squared, which is 4, would give me a 1/2. And so you can see you're getting points along this. And again, if you keep choosing and keep choosing, you're going to get points along both red branches. We came over and did the same thing with the negatives. We put a -1 in. Would we get a value of 2? When we put a, the other point we put in was +2, so let's put in -2. We would get -2 squared is 4. We'd get that number of 1/2 again. So 1, 2, 3, 4. Whoops, sorry, that was placed in the wrong spot, as you probably just noticed. That should have been the point 2, 1/2. -2, 1/2. It was the x that was negative to begin with, and the y value ended up being positive. And you do that same thing, and you're going to get these graphs. So one characteristic, instead of saying they're in opposite quadrants, we should be able to, again, remembering our quadrant numbers, say they are in adjacent, next to quadrants, quadrant 1, quadrant 2, in our work here. So you now have all 4 variation equations that we're going to be studying in a little more detail. And you should now be able to say, oh yeah, y equals kx squared. If k is positive, like we started, we should have branches called hyperbolas in opposite quadrants. Y equals k over x squared. We should have branches or inverse squared graph. Whoops, they don't go back up again. In your y equals k over x squared graph. So again, start thinking, especially for these two. Make a list. What are the characteristics that are true for all equations of that form? And then again here. And we want to be able to talk about those lists in class. What did you write? What did you think? What was similar to what we've already discussed? What was different from what we've already discussed? Because there are some characteristics that are similar, and definitely some that are different. So you should be able to give me that list when you come to class, and we will definitely be talking to it and adding and making our own. So good luck with that, and we should be able to answer some questions with our lists complete after our discussion.